Thomas versus physics. What if all biomass on Earth jumped at the same time? Based on a genius comment by @AlexQuinn2390. What about all biomass on Earth jumping at the same time? Imagine this. Every living thing on the planet, every squirrel, sequoia, shrimp, mushroom, mosquito, and millipede, all of them, all of us, jump at the same time. What happens? To find out, we need to ask three questions. How much mass are we dealing with? How much energy would be released? And could it actually do anything to Earth? Let's dive in. Step 1. How heavy is life? According to a comprehensive 2018 biomass study by Baron et al., the total carbon-based biomass on Earth is estimated at 550 gigatons of carbon. But hold on, carbon is only a fraction of living mass. Most of life is water. So when we include the wet weight, the actual mass of flesh, leaves, cells, and slime, we're talking about roughly 2.3 trillion metric tons. That's 2.3 times 10 to the 15th kilograms. For comparison, the weight of all humans, approximately 0.06 trillion tons. The mass of Mount Everest, 161 billion tons. So, biomass is 14,000 Everests jumping at once. That's horrifying. Step 2. The jump. Let's assume every kilogram of biomass gets 0.1 meters off the ground. That's realistic for most animals, and maybe optimistic for trees. The potential energy per kilogram is E equals m times aber g times h equals 2.3 times 10 to the 15th times 9.8 times 0.1 equals 2.25 times 10 to the 14th joules. For reference, SAR bomba, 2.1 times 10 to the 17th J. But over time, a jump is instantaneous. Little boy, Hiroshima, approximately 6.3 times 10 to the 13th joules. So, this biomass jump equals 3.5 Hiroshimas focused downward. Now here's the fun part. When they land, all at once, that energy comes slamming into Earth's crust. Step 3. The impact. If all biomass is evenly distributed, the energy disperses. You get minor tremors. Seismographs twitch. Birds panic. Dolphins say, WWTF. But if we gathered all biomass into one location, hello again, Kazakhstan, and it jumps simultaneously, you've just recreated a kinetic meteor strike. Let's simulate that using impact physics. Using an energy of 2.25 times 10 to the 14th joules focused in one place, you'd get a crater of about 1.3 kilometers wide, 200 meters deep, seismic waves, equivalent to a magnitude 7.5 earthquake destruction radius, city scale, ground uplift, meters, surface, liquefaction, landslides, volcanic triggering, possible. This is no longer a biology experiment. It's a continent-level natural disaster caused by frogs and ferns. Step 4. Could Earth move? Yes, but barely. Using conservation of momentum. Biomass momentum equals Earth's recoil momentum. mb times vb equals me times ve. Let's assume jump velocity equals 1.5 meters per second. VBE equals open parenthesis 2.3 E15 times 1.5 close parenthesis slash 5.97 E24 equals 5.8 E negative 10 meters per second. That's half a nanometer per second. It would take 550 years to move Earth 1 millimeter. We are not a threat. Step 5. But what if we jumped again and again with perfect timing every few seconds? A worldwide jumping rhythm. Could we build resonance with the Earth's natural frequencies? Earth's lowest normal mode, the breathing mode, is approximately 54 minutes. Our jumps? every 2 to 3 seconds max. So, resonance? Probably not. But could we trigger shallow crustal vibrations, stress fault lines, and cause sympathetic quakes? Yes, locally. If biomass jumped around the San Andreas Fault, let's just say LA might get beachfront property early. Bonus round. Rocket assisted biomass jump. Let's say we attach rocket boots to everything. Boost upward velocity to 150 meters per second. Same mass. E equals zero point 0.5 times m times v squared equals zero point 0.5 times 2.3 E15 times 150 squared, approximately 2.6 E19 joules. That's twice the Chicxulub asteroid impact energy, the one that killed the dinosaurs. But again, only if it lands in one place. Also, the visual of 2.3 trillion tons of biomass launching into the sky, screaming on fire, falling back down? Terrifying. Also, probably an anime. Final thoughts. Jumping all biomass at once. Globally, weird, fun, slightly shaky. Locally, catastrophic. Could it move Earth? Only if Earth weighed as much as a boat anchor. Could it break physics? Not really. But it might break your house. In the end, this scenario is like most of physics. Absurd in practice, beautiful in theory. Thanks again. At AlexQuinn2390. And remember, Internet, nothing unites life quite like a synchronized full body slam into the planet. This was Thomas versus Physics. See you in the next improbable apocalypse.